My name is Mitchell Pitt with ID number 7568615, and this is my 10K thermistor temperature measurement system. So firstly here on the block diagram on the right, and then I've got my front panel on the left here, showing the temperatures and also the LED lights. So firstly on the block diagram, I've got my analog input here for pin 3 and 5 that supplies the voltage source to it, and also the VO, voltage output. So that should be measuring 5 and 2.5 for the VO, and then we've also got the thermistor here, which is the 10K. So this part here is the voltage divider. Using this calculation here, this is how the voltage divider works, and then this then outputs to RT. These then get transferred, divided by the log, to for R3, which is the R log cubed, and then just R, which is just being logged from the resistance total. As we move further down into the system, we have then the Steinhardt calculation and also the beta calculation here, and these are used, the parts within this calculation are used by all the other different inputs of the ABC figures, which are taken from the data sheet of the 10K thermistor. You've also got the beta input, the temperature, and also the 10K resistor. So once the calculations are complete, these are then converted into Kelvin by minusing it down, and then this is then gone in to convert for the beta calculation into the different SI units, the 5 different SI units I've chosen, and also into the Steinhardt SI units here. Now the Steinhardt is more efficient due to the wider range of data in which it's using, so that is the better one to go by. Before these are converted, it firstly goes into Celsius, which is this on the front panel here, which is this calculation here, and the units down the bottom for both the Steinhardt and the beta are seen here. Once this has happened, you then get the ranges that I've put between 131 and then the range for hot, which will illuminate this LED, the range for ambient, which is 30 to 20, which will illuminate that LED, and then the range for cold, which is 19 to 0, which is the cold temperature LED, and then finally this will then feed it back into the different digital output pins, which will illuminate the LEDs depending on what temperature it is. Then finally there is an error calculator here, which will feeds into my RIO. So if there are any errors calculated, it will then stop and cut out the iRIO, so then there's no potential damage that could occur. Thank you for listening.